out of this definition will fall various neat things. Okay, so what does this really mean? So when I first came across radians, it was really a little confusing, and maybe it was really confusing to me what it meant, it could have meant, and things like that. Okay, so we are mirroring the screen, so let's see if this works. Okay, so so Wikipedia has this interesting little animation. Okay, so here's a circle, radius r, and here's the same length r, and now we apply it to the arc length here. So this is the definition of 1 radian.
How much degrees is 1 radian?
So we'll get to that because there's a conversion between these. So in half a circle, they're showing here that they're pi radians. So you can convert
That's such
that.
a better explanation than more.
So
Wait, she explained it?
So
No, yeah, exactly. She just showed us.
okay.
pi
So
equals 180 degrees, so, and so,
Yep.
and so to convert, you basically,
yeah. So just hang on, Charlie. We'll get to that. Okay. So for some of you, this might make a little bit more sense as to what a radian is. So a radian is such that the pi shape is that the arc length is the same as the radius.
and that makes sense because the circumference of a circle is 2 pi, 2 pi radius or pi diameter, which would mean that, which would mean that the arc length of the radius would have to be multiplied by 2 pi to get the circumference, which is all the way around the circle.
Okay. So as a result of that, okay. So this is the definition of radians, of 1 radian. So if you were to take this, let's use it. So it's about here, somewhere in here, okay? So this is R and this is R, so this arc length is R, so as shown in the little animation.
And the angle is R.
And the angle here is 1 radian. Okay, not R. Okay, the angle is not R, it's 1 radian. So
180 divided by pi.
So if you were to think of this as a wheel and you were to roll it, okay, up and you roll it and then you get back to your original position, what distance, what linear distance would you have gone? You'd have gone the same as the circumference of the circle, right? Okay, and so the circumference is equal to 2 pi r. Horrible. Okay, circumference is 2 pi r. And so how many radians have you gone through? So let's use that. Okay, and so 2 pi so how many what am I
Like basically.
so then if you go all the way around, you go through 2 pi radians, and this is all the way around. Okay, let's see, this is not a great explanation. Let's see,
Yeah, the animation.
the animation works better.
The
No,
animation.
it
was
explained
awesome.
it, like,
Yeah.
yeah.
Okay.
Okay.
So you have 2 pi radians in 360 degrees of circle. So you have this ratio, pi radians is equal to 180. So in this,
So 1 radian must be 180 divided by pi.
that's right.
That's someone.
So in here you have pi radians. Okay, so the importance, the value of this, is that when you do, when you measure things in radians, the arc length, falls out much easier than with degrees. Okay, and so when you do the problems in 5.2, it's a lot easier. Okay, so so when you convert between radians and degrees, you can use this conversion. But this conversion comes from this definition. 1 radian is the angle subtended by an arc equal to the radius of a circle. Okay. Okay. Finding. So the next topic, they want you to find various arc lengths. Okay. So arc lengths. Okay. So if you have a circle.
Why?
Sorry.
Like, why radians?
Why radians? Okay.
Like, what is the advantage of using radians in any problem?
It gives you arc length.
Okay,
It's
you'll
easier
see
to
it
measure out
right
than
here. You'll see it right here. Thank you for the lead-in. Yes.
Oh, I guess also radians is how the computers calculate sine of that.
Well, it's how they automatically do it if you don't set it to degree.
Well,
Like I think internally they just convert it into radians and then they do it.
well, okay. The reason you might say that is because in your calculator, the way they calculate sine and so on is using a Taylor series, and the Taylor series is all computed using radians. And why do they use radians? Is because it falls out of there very cleanly. Okay, so just like last class we were talking about imposing a coordinate system. So if you in math, if you impose a transformation, if you impose certain units, things like that, that causes the calculations to often fall out quite naturally, okay? But that's sort of an aside. But if you go into calculus and so on, you will see that more and more often. Okay, so arc length. Where are we on arc length? Finding arc length. Okay, so if you have some angle theta, then so the question is what is S? So 1 radian is the angle subtended by an arc equal to the radius of the circle. So if this is R, radius, and this is measured in radians, okay, then the arc length S is equal to theta over R. Okay, so basically, how many radians did I go through? So if this was 1 radian, okay, then the arc length here is 1 over R. Okay.
So if you.
Sorry. Did I get that? Sorry, I wrote that down wrong. This is not correct at all. S is equal to, see, when I said that, it didn't sound right. You could also write it as, in the book they have here, theta is equal to S over R. Okay, so let's go over that one more time, because I screwed up. Okay, so the arc length here is the radius times the angle when it's measured in radians, and so that's.
And that means you can also convert arch degrees to radians.
So the arc length scales with the radius. Okay. So Diksha just missed the answer to her question. It's like, should we just like sit here and wait for her to come back?
No.
No.
Just keep
I mean, this was the crux of her question, right? I mean, how much simpler do you want it to be?
It's literally fractions.
Right, and so the arc length scales with the radius, yeah, okay, that makes sense, but it's just simply multiplied by radians, and you just get, and this radians is essentially unitless, so you get length, this is a unit of length. So this radians is unitless, okay? Okay, and so this arc length here becomes length.
The reason that works, I
The
think,
less
is
units,
because-
the better.
Because it's pi radians for 180, that would mean at radius, this pi would be equal to, it would be equal, okay, now I'm lost.
Okay, so if you have 1 radian, so let's suppose this angle was 1.5 radians. By the way, Deeksha, you missed the crux of your question. I hope the bathroom, I hope the water was worth it. If you have, say, 1.5 radians, so somewhere out here, okay? So the arc length then is, well, it's going to be 1.5 times the radius. And it's that simple, and that's why we use radians. And it all falls back because of this definition. Okay, so the 1 radian is the angle subtended by an arc, if you want, an arc length equal to the radius of the circle. So by that definition, if I have 1.5 radians here, this is going to be 1.5 times the radius. Okay. Okay. So if you have the proper definitions in math, then things just fall out quite naturally. Okay. So so there's a section in the textbook about area of a sector. Okay, I'm going to refer you to the text, and you can read that. It's very similar. Okay, the area of a sector falls out. Okay, let's see. Angular and linear velocity. Oh, now we're getting into physics here. Did you do angular velocity in STEM physics?
I'm taking AP physics right now. I didn't do STEM.
You did do STEM physics? How did you get into this class?
Yeah, we did it. Why not? We thought it functioned. Yeah.
Okay, so
I didn't do this.
the best way of looking at this is again a circle. Okay. So you have some point here, and it's moving along the circumference of a circle. Okay, and so the angular velocity, which is angular velocity, is often denoted as small letter omega. Okay, lowercase omega. Okay. Okay. So the angular velocity is defined as the the angular rotation per unit time. Okay, so in this case, it's theta over time. Okay, so let's be clear about that. So the angular velocity is theta over time. So angular velocity is the angular rotation. How much angle do I sweep out? Okay, so another way to think of it is I have to think about this. is how much angle do I sweep out per unit time? Okay, so this is kind of just like another way of thinking about it, and it might help you understand what angular velocity is. So the analogy is like just straight up velocity. Straight up velocity is like for me, driving to Portland. Okay, there, in that analogy, it's like the distance. How much distance do I go in a certain amount of time? Okay, so in this case, it's not distance; it's how much angle do I go in a certain amount of time. Okay, so there's an analogy, and then there's here's the definition: angular velocity. Let's see. Okay, let's see.
So it's just like a measure of, it's a measure of what the angle of the movement, assuming an object moving like across an arc.
Yeah, so think of things rotating, merry-go-round or Ferris wheel, okay? Ferris, you might see a problem where it says Ferris wheel goes around in 30 minutes, and so there the angular velocity is 2 pi radians per 30 minutes, and you can express that as hours or seconds or however you want. Okay, so it's how much does it go around? Okay, notice that this doesn't have anything to do with radius, right? Doesn't matter how small or how big it is. It's all a function of how much did it go around. Okay, it's all just going around. Okay. Okay. Any questions about this? This, to be honest, took me a while to wrap my brain around. I had to do a few problems, and before it actually got cemented, and then they got uncemented.
Figured out how arc length works,
Sorry?
I figured out why the arc length equation works, because when the length S is equal to the circumference of the circle, all the degrees and radians will be equal to 2 pi, which will make a circle equation.
Yeah, so it literally falls out of the definition of what a radian is, because the radian is defined as an arc length. Okay, so so what about linear velocity? Okay, so so the linear velocity, think of this point here. You are sitting on okay, we'll use a Ferris wheel. I was going to say a record player, but I don't know, if you're like really cutting edge, you own a record player. But if you are sitting here, you're an ant, what kind of a linear velocity are you experiencing here? Okay, and this linear velocity should really depend on the radius, because if you have very small disk and it's rotating around, it's not very fast. But if you have a big disk and it's rotating around at the same angular velocity, then it's like could potentially be going really, really fast. Okay, so the velocity here is equal to the distance. So this is the arc length divided by time. Okay, and this is time. Okay, so this is very much like our analogy of me driving to Portland, right? I have a distance from here to Portland, and I complete it in, say, 30 minutes, okay? But in this case, I'm constrained to be on this circle. And what does that constraint mean? It means that this S, the distance is really an arc length.
So the velocity is arc length over time.
Arc length over time. And because of that, we know arc length is equal to r times the angular, well, okay. So arc length is, yeah, okay, sorry. Arc length is, how come I read this and then I miss it? Okay, arc length is r theta, and so the velocity, the linear velocity is equal to r theta over t. Okay, and the thing to point out here is that this theta over t, right? Okay, let's. So the arc length is r theta, so I can sub that into here. Okay, so the velocity, the linear velocity, does depend directly on the radius. So if I have a bigger radius, a longer radius, then I'm going faster, right? Okay, and and then this is theta over t, so I can also rewrite this as r omega, because omega is this theta over t. So this is they call this out as the relationship between linear velocity and angular velocity. Okay, so this is all pretty theoretical stuff, I suppose. Okay, so let's do a simple example. So example 11, okay, is a water wheel completes one rotation every 5 seconds. So here's your water wheel, and it goes around, goes all the way around every 5 seconds. So find the angular velocity in radians per second. Okay, so the angular velocity, does it say? Okay, so the angular velocity is omega, which is equal to theta over t. So this is equal to 2 pi in 5 seconds. So 2 pi, so this is 2 over 5 pi radians per second. Okay, so you can also find if you were given the radius, let's say the radius is r is equal to 10 meters. Okay, that's pretty huge. Let's say whatever. Okay, 10 meters. Then you could say if you're hanging onto the water wheel because you got stuck there for some reason, and the water wheel started turning around every 5 seconds, what is your linear velocity? So you can literally do the velocity here is equal to r times omega, which is equal to 2 over 5 pi times 10, which is equal to 4 pi.
Your notes.
What are the units here of this? This is going to be, this is something like meters or distance per time, which is seconds, okay? So this is going to be 4 pi meters per second. Because 5 is in seconds. Okay, so that's just the application of that. Okay, so this is the takes you to the end of 5.2. Okay, and 5.2, if you can get the formative done by that is 2:11 is it's Saturday morning, because you have let's see. Do I see? This is Wednesday.
So you say it's Friday as well?
Yeah. So, because I'm not going to get to the formative until Saturday. Yeah. So I'll give you till Saturday. Okay. So some of you guys have not done the formative for. Sorry. This is periods 4 and 6. Sorry.
We're on the left.
You're on the left here. 2:10 Friday. Yep. Okay. Some of you guys, so it's due here. So some of you guys have not done the formative for this. Okay. So the formative is required for dual credit, and it's also, if you don't do it, then you don't really know how to do these problems, and so you're going to not be able to do well in the quiz. Okay. Okay. So who needs help on section 5.1? Everett, really? Really,
Yeah.
Everett? Really?
But I got an answer for 7,
Okay.
but it does not match up with.
Sorry, I always forget about the stuff here. Remember, you guys, there's algebra help available Tuesday, Thursday at lunch here. Okay, if you need a pass, come and see me. And then there's has anyone watched the video of the test? Has anyone?
So busy.
Okay, was it
It was helpful.
helpful?
I appreciate
Okay,
it.
so it's got at least a 1-star rating, maybe more.